Hey guys, Mr. Grand here. 13.3, we're talking the unit circle today. So in this video, we're going to be filling out a unit circle and talking about why it's a thing, why it works the way it does. And then in the next couple videos, we're going to be going over how to use it to figure out sine, cosine, cosecant, secant, and tangent, cotangent ratios. So what is the unit circle? The unit circle is a circle on a graph that is centered about the origin, and what's special about it, why it's called the unit circle, is the radius is 1 unit. And so all of the coordinates on the axes have 1 and 0 as part of their coordinates, right? You're going 1 across and 0 up or down, 0 back and forth and 1 up, and continuing like that. Now, what's special about this is we can really think about this as any line, any angle of rotation we can put on the unit circle and then put our little angle symbol there. And from that, we can use the coordinates to figure out all of the trig ratios of the various angles that could be on the unit circle. So really any angle can be used on the unit circle. All right, so you don't need to put this part in your notes. I just want to talk through this. So I'm going to focus on the first quadrant of the unit circle, so just the top corner of it. And like I said, if we take and make any angle of rotation, we'll put it there just to make it nice for this example. The end of that, the end of this is going to end at a point that's on the unit circle, and it's going to be some xy coordinate. The radius, this line, is 1. Now, if I go from that point, or any point at any angle, and I trace straight up or down to the x-axis, I can make a little 90-degree triangle, right? Now, what's special about this, one, the hypotenuse is 1, and that's a super useful thing when it comes to establishing sine, cosine, and tangent. The other thing is the base of this triangle is the horizontal distance here, which is the same as the x-coordinate. The height of the triangle is the same as the vertical coordinate, which is y. And that means that from this angle, okay, this angle's on the left side, the opposite is then the right, y-coordinate is the same as the length of the opposite side, and then the adjacent is the length of the adjacent side is the same as the x-coordinate. Now, where is this useful? All right. If we start thinking about sine, cosine, and tangent ratios, sine, we know, is equal to opposite over hypotenuse. Well, in this triangle, that's the y-coordinate for the opposite side over the hypotenuse, which is 1. And that's just equal to y. So whatever this angle is, if we know the coordinate at the end of it, the sine ratio is just the y-coordinate. Same thing with cosine. Adjacent over hypotenuse. The adjacent side is the same as the x-coordinate, and then the hypotenuse is always 1. Well, x over 1 is always going to just be x. So whatever this coordinate is, the x value tells you the cosine ratio. And then tangent's a little bit tougher because you got to do a little division. Tangent, opposite over adjacent. And that ends up being the y value over the x value. So no real shortcut there, but it is kind of handy for sine and cosine. Okay, so today's goal is just to get a unit circle in your notes to go off of, right? So when you're doing your homework, when you're doing the test on this stuff, you've got it there. And what we'd like you to do is actually take the time to fill this out. You might have to pause. I'm going to talk through some of the patterns that are here, but just pause, get yourself ready with a circle, and then we'll kind of go from there. Now, if you look at this when you're making your circle, if you're having to draw it by hand, start with the x-y axis, the x and the y axis, and then start making the lines for the angles. Now you can start out by making an X that comes right through like this, that would be at like 45-degree angles. And then there's going to be like not all the way in between, so these ones were halfway between. The next ones aren't going to be all the way in between. They're closer to this one that's at an angle than this one that's straight up and down. But they go straight across like that. And there's one here. And there's one here. And there's one here. And now I'll erase all of that on mine because I got to write a bunch of other stuff on there with my whiteboard marker. Okay, we're going to start out with angles. That's what we're going to fill in these little boxes here, all right? If we start here, that's the beginning of our angles of rotation. That's going to be 0 degrees. The next one up, I like to think about these as like pizza slices. The big slices are 30 degrees. So from 0 to here is 30 degrees. Then the little slices of pizza are 15 degrees. So if we add 15, that is now 45 degrees. If we go another 15 degrees, it's 60 degrees. Then big slice of pizza, so it goes to another 30, which makes 90 degrees. And that kind of makes sense, right? Because this, from here to here, this is a right angle, so it should be 90 degrees. All right, another big slice makes 120. Little slice makes 135. Little slice makes 150. Big slice makes 180. 180-degree angle is a straight line, so that kind of makes sense. 180 to here, big slice, is 210. Little slice is 225. Another little slice, 240. Big slice, 270, almost there. Another big slice, so add 30 degrees, is 300. Little slice makes 315. And another little slice makes 330 degrees. And then if we went all the way back around, it would be 360. So some people also add a 360 in with this 0. So if it just starts here at 0, if it makes it all the way around, it's 360. Okay, coordinates. Filling these in. This first one, 1, 0. That's hopefully not a too tough of one. When we get up to this next one, it gets a little weird. It is the square root of 3 over 2 and 1 over 2. Then the next one at the 45-degree angle is the square root of 2 over 2 and another square root of 2 over 2. Right? A 45-degree triangle, the y-coordinate and the x-coordinate are the same. All right, and then 60, it's the same as 30 but flipped. It's 1/2 and root 3 over 2. And then when we get up to 90, now instead of 1, 0, it's 0, 1. Now, a big part of this, there's a lot of patterns here, right? I already talked about big slices being 30, little slices being 15. These numbers repeat. There's only like 5 numbers in the coordinates, right? 1, 0, root 3 over 2, 1/2, and root 2 over 2, and they repeat in a pattern. That pattern continues over here. I want you to think about what happens if I take a point right here, this xy coordinate, and I move it straight across to right here. What changes about it? It's the same x and y value, but now the x value is negative over here. So this one is, this is going to be tough, negative 1/2 and positive root 3 over 2. Then this one, same thing. This one moves straight across, and it's negative root 2 over 2 for the x-coordinate and positive root 2 over 2 for the y-coordinate. This one moves straight across. It's negative root 3 over 2 for the x-coordinate and positive 1/2 for the y-coordinate. And then same thing with this one. We can move it straight across, and it goes from 1, 0 to negative 1, 0. All right. Same patterns here. I can take all of these coordinates and move them straight down. What happens when I take this point and move it down to here? When you move it vertically, the y-coordinate changes, right? So it's going to be the same 2 numbers, except now the y-coordinate is going to change to negative. All right, so that goes straight down. Negative root 3 over 2, negative 1/2. This one goes straight down, and it's negative root 2 over 2, negative root 2 over 2. This one moves straight down, and it's negative 1/2, negative root 3 over 2. This one moves straight down, and it's 0, negative 1. And now we can take these and move them over to the side here. That's going to change the x-coordinates to positive. So this one goes to here, and it's positive 1/2, negative root 3 over 2. This one moves over, and it's positive root 2 over 2, negative root 2 over 2. And then this one moves over, and it's positive root 3 over 2 and negative 1/2. All right. We'll do another video just to give you a little break on the tangent ratios here. I would suggest that for your homework, again, that you fill all of this out. It takes some time, it's annoying, but you know, if you do it, it's done and you can just sort of move on with your life. It's a lot harder to try to just, and especially like if you just look one up, you can do that, but it's going to be easier if you've actually taken the time to write this out so you get a little more familiar with things are, so you're not just kind of searching all over the place. So another video for the tangent ratios, and then we'll do all the trig ratios, actually using it.